Hi Pirates, you will never guess, but we have made it to the last lesson of the year. Who would have thunk in August that this is how we would be concluding our adventure? But I hope to see all of you at some point in the near future. This last lesson is our last application of derivatives. And this first one is called Newton's method. Newton was a pretty smart guy. Again, he didn't have the TikTok or the Snapchat or the Instagram, sad but true. So Newton came up with ways to solve equations. So his method is used to solve any equation if it's set equal to 0. This is actually also how our calculator operates when it's kind of spiraling towards a solution. It doesn't always land exactly where we want it to. Now for Newton, again, he had a lot of free time, so he would make an initial guess, and then he would use this formula. You might recall from Algebra 2 something called a recursive definition, where it's depending on the number before it to spiral backwards. Now, for convenience sake, we will give you an initial guess because we really just want all of your work to look the same. Sad but true. So you're given your f of x, and this first one's not too crazy. The intent is you might be able to do this with a calculator. You might do it without, either way. I take the derivative. In this case, I get negative 2x. So I am given x1. If I want to do 2 iterations, an iteration is like a round, like if you reiterate, you go around again. That really lands me at x3. So x2, if you want to just kind of see how this works, is x1 minus the function at x1 divided by the derivative at x1. Well, x1 is 3, so I have 3 minus f of 3 divided by the derivative of 3. Newton kind of figured out this method. And if I do my arithmetic, I think these both end up to be negative 6. So I actually end up with 3 minus 1, which is 2. Now, obviously, with a recursive definition, if the first round is wrong, what's going to happen to the next round? You guessed it, it's going to be wrong, but you guys are smart. You can handle this. So my x3 has to do with x2, because again, this little n is the one before what I started with. So now I have 2 minus f of 2 divided by f derivative of 2, which ends up being 2 minus negative 1 over negative 4. Be careful with the positives and the negatives, which turns out to be 7/4. Just for kicks and giggles, because I like to kind of think through what does this actually mean? Okay, what does this actually mean? In just 2 short rounds, I have approximated one of the solutions to this equation. Okay, well, let's talk about what the actual solution would be. So I could solve this with algebra. I get x squared equals 3. X equals plus or minus square root of 3. Some of you might recall that would be 1.73. Let's see. Square root of 3. 1.732. OMG! In just 2 short rounds, I was super close to the actual solution. Now, if my initial guess had been in the negatives, it would have led me to the negative solution. So Newton's method, not that it's a lazy method per se, but it goes to the closest solution that it can find. So that's how it works. All right, last topic of the year. This one we just kind of dabble on, doesn't show up a ton, but you'll see more of it later on down the road in BC Calc. It's called a differential. A differential is what you get if you solve for just the dy part of the derivative. Now, it does require that you know how to find a derivative. So I thought for fun we'd bring in an old school log derivative. Memorize your elsers. Be sure you go back and look at those as you trend towards the end of the semester. The derivative of a log was 1 over the something times 1 over the natural log of the base, which is 3, times the derivative of the something, chain rule. So in this case, my dy dx is 2 over x natural log of 3. You could have used log properties in the beginning, totally fine. So the differential, as goofy as this sounds, is actually what I get when I separate this bottom denominator. So I have 2 over x natural log of 3 dx. It's as simple as that. Last but not least, friends, I can evaluate, given some information about x and the change. This is really the change in x, the width. So my differential would be 2 over 5 natural log of 3 times 0.01. Again, we're going to round to 3 decimal places unless otherwise specified, and I get a value of 0.004. You've done great work. I miss you guys. Keep it up, and I will hopefully see you soon.